Hello everyone, this is a video lecture for College Algebra Math 1414 Section 8.1. We are going to be doing systems of equations. That's good enough. Systems of equations. And in particular, we're going to be doing it without the calculator. Now, I have to say that you can do all this section and all of Chapter 8, most of Chapter 8, with a calculator. Say, like Desmos matrix calculator is a very popular one. TI 8384s, the Casios, everything will do this. But we're going without a calculator because this is still under the Exam 2 heading, I guess you could say. You're going to be seeing this content in Exam 2, and Exam 2 is not calculator required, I guess you could say. We're trying to not have calculators on Exam 2 or Exam 1. But the final exam, we're pretty universally set that there is calculator on the final exam, and so when you see this again later, you can go much quicker. Most of the time, it'll be Chapter 9 that's going to be the same kind of stuff, but more oriented with calculator. But for now, we're doing no calculator. So here we go. 817. Let's just jump right into it. X plus 3y is equal to negative 2, and y is equal to negative 2x minus 14. And they're wanting to know what is x equal to and what is y equal to. That is a system of equations. There's two equal signs, and there's two unknowns. And so you can figure this out, at least theoretically. And so there's definitely a couple ways to make this happen. The easiest that I know is that's y and that's a y, so I'm going to just plug it in. I'm going to substitute. And it would look just like this. Now I can just solve for x. It's super easy now. Distribute your 3. So that's going to be a negative 6x there. I also got a negative 14 times 3. 14 times 3 is 42. I use the calculator, by the way. A scientific calculator, you know, like a add, multiply, divide, subtract stuff. And that's an x. Okay, so combine like terms. I got a negative 5x. I'm going to add the 42 to both sides. So negative 5x is equal to 40. Divide by the negative 5. And we get x is equal to negative 8. Cool. Because of that, I can now take this original y equals formula and solve for y. Negative 2 times the negative 8 minus the 14. Two negatives make a positive 16. Minus the 14 is a 2. So y equals 2. We got our two numbers. Negative 8 and 2. That is not how my math lab wants the answer. Let me show you. They've got curlies with a box. And they say type an ordered pair. So what do they mean by that? They mean parentheses x comma y close, like a point form. It's like a point. And so our particular answer in this case would be negative 8 comma 2. Notice again I got my x and my y values just like that. For all of Chapter 8, when we're doing these systems of equations, you're going to need to put it in this format. When we get to Chapter 9, it'll be more like this style, or something similar at least. But right now, you need to put it in point form. So that's your first system of equations. It's pretty easy. Honestly, this is the tail end of the class. We're getting near the end, and it's all good. It's all easier from here on out. Except for the next section. So, but we'll talk about that later. So I have the next one. X equals this and x equals that. What do I do? Well, they're both x equals, so I got 3y minus 7 is equal to 5y minus 9. I mean, if they're both x, then they're both equal. I'm going to minus the 3y on both sides. I don't know why I canceled that. It's not exactly canceling. I got a 2y minus 9. Add 9 to both sides. So what, 2? Y equals 1. Cool. I can now plug that in wherever I want. I don't know, just plug it in the bottom one, I guess. So x is equal to 5 times 1 minus 9. 5 minus 9 is a negative 4. Cool. So then, again, in the curlies, we're wanting a point form here. Negative 4 for x and 1 for y. X and y. Next one, 8, 1, 11. I got 2x plus 5y is equal to 0. And I've got x minus 3y is equal to 0. I've got to say, this is the easiest one of your day. The answer is 0, 0. Y. X. That was a joke. Y, X, okay. Why is that? Why is that? Well, if you see these zeros here, it will always be this way, as long as it's set up in this type of format there. It's not that these are your answers. I mean, look over here. Those were not my answers. It's not like that. It's just that if it's zeros, then you'll get zeros. That's just a very particular funny thing there. And so it makes it faster. We could do the math, of course. I'm going to add 3y to both sides. I'm going to prove this to you. So x equals 3y, and then I can plug that in right there. So I got 2 times 3y plus 5y is equal to 0. That's 6y plus 5y is equal to 0. That's 11y is equal to 0. Divide by 11 on both sides, and what you get is 0 over 11, which is still 0. And when you plug that in, you still get a 0. Okay. Next one, 8, 1, 21. So I've got 4x plus 6y is equal to 16. And I've got a 3x minus 6y is equal to 12. And, you know, let me put this addition method. I call it addition method. I'm going to write that on the side here. A lot of these problems, as you go through this, are sequentially showing you different methods. They say use addition method or use substitution method. I don't know, whatever they're asking for. And in this particular one, I think they're going to say use addition method. Eventually, they'll just say use whatever method you want. They're wanting to show you certain styles of how to do these quicker. I mean, what we've been doing was something kind of like substitution. You solve and plug it back in and that kind of thing. But here I'm going to use addition. So what I'm going to do is put a big old plus sign right here and just add straight down. So here we go. 4 plus 3 makes 7. 6 minus 6 is 0. Why? It's kind of weird there. And then I got 12 plus 16 is 28. Now, you don't need to put the 0 there. The reason why we did addition method here is because it cancels that thing out. 7x is equal to 28. Divide by 7. And I got x is equal to 4. Look how fast that was. That's super fast. I could then take, I don't know, the top or the bottom. Let's just take the top, I guess, and plug that in. So I got 4 times 4 plus 6 times y. My y was looking a little weird there. Is equal to 16. So I got 16 plus 6y is equal to 16. Minus 16 on both sides. And we get 6y is equal to 0. The only way to make that happen is if y actually equals 0. That's kind of weird to get, but it still works. My answer then would be 4, 0. Sorry about all that. Super easy there. Okay. Let's do another one. 8, 1, 23. I got x plus 4y is equal to 7. 2x plus 3y is equal to 9. And they say to use addition rule. I guess I'm writing it kind of sloppy here, sorry. Now, addition rule here? What are you trying to say? I mean, if I put a big old plus sign here, that's cool and all, but we're not going to get anything that cancels. So what I want to do is I want to teach you how to use addition rule, but kind of change it and manipulate it a little bit if you need to. And what I'm going to do first is multiply the whole entire top equation by -2. This is still okay. This is a legal move. This is an okay move. The reason why is because I'm multiplying it by every single piece. This one, and that one. If you had a 2 in every single slot, you can cancel your 2's out on both sides. So this is okay. You can do that. You can multiply by whatever you want. But I chose -2 because I get -2x, -8y, and a -14. Now I got 2x plus 3y is equal to 9. And if I put a big old plus sign here now, notice that the 2 and the -2 cancels, make us a 0. That was the reason for it. I did it because I wanted to make it easier as soon as I started doing the addition rule. And so 14, and then the 9 should be a -5. Divide -5 on both sides, and I get a +1 as my answer. And I'm going to use the top because I think it's going to be easier to plug it back in. X plus 4 times 1 is equal to 7. X plus 4 equals 7. X equals a negative... no, it's a +3. Sorry. And so, just as always, we got 3, 1. That's my X, Y. Cool. Now, let's do a much more complicated one. I've got 4x minus 5y is equal to -7. And I've got 3x plus 4y is equal to 18. All right. How do I do this? I don't know if they're going to say addition method or whatever. I'm going to do the addition method, but first I need to multiply both the top and the bottom by some kind of numbers in order to cancel it. Let's say I'm going to cancel these x's. That's going to be my goal. I'm going to cancel my x's, just kind of like last time. What I'm going to do is then multiply the top by, say, a -3 and the bottom by a 4. So why those particular numbers? Well, this right here is telling me to do this here. And this here is this one right here. If that was just the case, I'd have 12 and 12, and I'm actually not canceling. What I need is a -12 and a 12. So you can put a negative in the top or the bottom, whichever one you want. But as long as you could see that like these numbers are the same here, one of them is going to be a negative in the end, and it should end up canceling all my x's whenever I put a big old plus sign on it. See, that's what it looks like now in the front. It looks like that, so that whenever I add them together, I'm going to get a 0. Now, I still need to do the rest of the math. The point I wanted to show you is why I'm doing it like this. Okay, so -3 times a -5 is a +15y, and then 2 negatives here make a +21. 4 and 4 makes a +16y, and then 4 and 18. That's a calculator. 4 times 18 is 72. Okay, so I added these guys, make a 0. I'm adding these to make a 31y. And adding these together to make a 93, which is nice and convenient. Divide by 31 on both sides, and you can see that I'm going to get a 3. Top or bottom, I'll take the bottom this time, I guess. I don't know. 3x plus 4 times 3 is equal to 18. 3x plus 12 is equal to 18 minus the 12s. 3x is equal to 6. Divide by the 3. X equals 2. And, of course, my final answer, 2, 3. Okay. A lot of this is going to be busy work. Once you get the first thing done, after that it's just solve, 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 plug in, solve, solve, solve. There's nothing terribly new after that a little bit. I have a note here in my notes. It says sometimes you need to click the infinite solutions. So this is a hard break here. Infinite solutions. Or you might need to click the no solution. So they provide these as options each time. You're going to rarely use it, but it might come up. So let's talk about when they will or when they won't, because I haven't done any particular ones about these. Let's just say I got 1x plus 2y is equal to 3. Then I got 7x plus 14y is equal to 21. This is actually going to be the infinite solutions answer. Why is that? If you notice that I want to do, say, addition rule. And so I'm going to multiply by -7 in the top, and they should cancel here to make it 0. But notice that here, when I multiply it here, I'm going to be getting a -14 and a +14. Makes it 0. So I got 0x plus 0y. And then this guy right here, if you go all the way to the end, I got -21 plus 21 makes a 0. So look at my bottom equation here. I got 0x plus 0y is equal to 0. 0 equals 0. That's actually true. That's a true statement. Yay! 0 is equal to 0. True. It doesn't tell me anything. It doesn't really give any... It's not like a solution. It's just a true statement. Yay. I don't know what else to say. So what we do click is infinite solutions. Basically, I don't know what the answer is. I don't have enough information to tell you what the answer is. But so far, everything checks out. That's all you can say. If they say, give me an answer, well, I got an infinite amount of answers that could work. Any number will work in there. This is kind of weird. We'll be seeing a lot more of this in Chapter 9 in particular. Here's another example. 1x plus 2y is equal to 3. 7x plus 14y is equal to 22. Notice it's just a tiny bit different. Same as last time. Red, magenta, either way here. Distribute. Big old plus sign. I got a 0. Of course, that's the reason I was doing that. I got a 0 here. So 0x plus 0y is equal to, and what we got here is a -21 plus 22 is a 1. Sorry for it being sideways. And so I got 0 is equal to 1. That is false. That is a false statement. I don't know what the answer is, but it ain't nothing like this. And so that's when you're going to say no solution. Null. That's null is what that is. It's not a 0. It's a null. Just no solutions. Undefined kind of stuff. You know what? The exact wording, as long as you're just clicking it. I mean, when you go to My Math Hub, it's pretty obvious. Just click whatever you got to click. So yeah, if you get something that's just plain out wrong, we got to tell them it's wrong. Okay. Cool. All right, next problem. This is a word problem. It says we have a fixed cost of $14,000. And then they're talking about bicycles. They're saying each bicycle, I think it's bicycles at least, costs $20 to produce. Might not be bicycles. I don't know. Because they're only saying selling it for $40 each. I don't know if that's a bicycle. Selling for $40 each. And then they want a lot of stuff with it. Part A, they want C of X. That is the cost. They want the cost. So here's the thing. Let's just say it's bicycles. I'm just making something up here. I got some bicycles at a plant. A manufacturing plant. This right here, this fixed cost would be something like the rent of the building, the electricity, water bills, fixed cost every month. Cost to produce each of these are the materials like the metal and the rubber and whatever else to make a bicycle, plastics. And then you're selling it for this much. This is the price that you see at your store. And saying, hey, that's how much it is for a bicycle. I know $40 makes no sense, but that's my point here. Okay, so you're making a profit of $20, you think, off of each unit. But because there's a fixed cost, you're going to have to make a lot of these bicycles just to pay off that monthly cost of rent. So let's see it. So cost, what's the cost of this per month, or is what they're kind of getting at. Well, I got my fixed cost, and I got this production cost. So fixed amount of $14,000 plus $20 times X. Times X being, X is the number of bikes. Again, I don't know if it's bikes. I'm just making this up right at this point. So there you go. For each bike, $20, and then the fixed cost. The next one is revenue. Revenue is like money that you make, comes in. And so we got 40x, $40 for each bike sold. And then they're going to want to talk about this break-even point, which is actually pretty cool. What they're saying is, how many bikes do you need to produce to be able to start making a profit? And so that means that your cost is equal to your revenue. That's the main idea here. I got my 14,000 plus 20x is equal to 40x. Solve for x. Minus 20x on both sides. Divide by 20. And I got 700. 700 bikes need to be produced in order to break even. Okay. That does not look like bikes. It's okay. All right, so bikes. Cool. All right, is that what we put in the box? Nope. Okay, what they want also is a Y value. They want to know how much dollars that was. Now, here's the thing. Break even. Think about it. How much dollars do you end up with in the end with a break-even scenario, like nonprofit or something like that? 0. You end up with 0. So you should basically, I mean, I would think, put in a $0 because all the money we spent is all the money that we made, and there's your break-even, and we're good. And my math lab says, you're wrong. Kind of unfortunate because I feel like the point of the problem has been severely diminished. But I don't make these problems up. I just administer them. I have an x equal to 700. Plug it into whatever one you want. I'm going to choose the bottom because it's super easy. And so I'm going to say 40 times the 700. And I got $28,000. And that's your y. That's, what would you call that? I'm going to call that money. Dollars, bikes and dollars, that kind of thing. But really, it's more like a flow. It's like a money flow. Your final answer, by the way, is 700 and then 28,000, just like this. Okay, they want it in point form. Almost everything in Chapter 8 is in point form. What do I mean by flow? It means that you spent $28,000 that month, but you also made $28,000 in that month. And so that's how it works. That's the flow. It was 28,000 out, but it's also 28,000 in. You break even. You get $0 in the end of the month. You spend all your money. You had to take out a loan. Then you got your money. You paid off the loan, and you're sitting there at $0 again. So you own $0, but how much was the flow? That's what they're asking. If you think it's silly, so do I. 8, 1, 67. I got negative 5x plus 10y is equal to 160. And then I got x plus 3y is equal to 184. Now, this is another word problem in particular. Something about years and percentages and stuff kind of like that. I don't really remember every single piece of this. But they do say X is years after 1970. and that y is some kind of a percentage. So not a decimal. It'll actually, I mean, you might get a decimal answer, but I mean, it's going to end up being like 50%. It's actually just 50. Okay, don't put 0.5. That's not the point here. Okay. So x and y, cool. We got it. We got this equation. Good to go. Now what? Well, we start solving however you want. Back in the day, my math lab was a little bit more picky with this problem, and I would constantly get it wrong, regardless of how I approached it. They wanted it a very particular way to be solved. But because I complained over the years, I'm thinking that they have changed it. Because last time I've checked this, it was a lot more lenient with my answers, so they probably changed the error tolerance a little bit, which is good. Otherwise, this problem is just annoying. So I multiply the 5, so I can do my addition rule, make it 0. Here I got 25y, and here I got 160 plus 920 is 1080. Divide by the 25. And I got a fraction. Well, I think they're wanting decimals right now, so 43.2, and this is a percentage, okay? We're not done. Let me go ahead and take this right here. And so I've got my x plus 3 times y is equal to 184. Now, this is where it gets a little sticky. Back some years ago, and it might, I don't think it's still this way, but I don't know. I think they might have wanted a rounded answer to be put into here, and that was not the way you're supposed to do math. You're supposed to put in decimals and not round. You're supposed to not round. Any good math student knows don't round until the end. And if you didn't know that, well, I'm telling you right now, don't round until the end. Subtract on both sides. And I got x is equal to 54.4. And now this is in years. So this is a percent, and this is years. Cool. Now, how do I put this all together? So they're going to have words, blah, 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 in the year of box. And then they're going to go blah, blah, blah. And then they're going to have a percentage. Some of these are easier than others. So you don't just put the 54 in here. That's not going to work. What you actually need to do is add, the original here was after 1970. So you add 1970 to this thing. And I got 2024.4. You need to, I guess, round it normal. So 2024. And then this guy right here is just going to be a whole number. Round it again. So I am rounding there, okay? If you get it wrong and it's off by 1 decimal, please send it to me. Send me like an Ask My Instructor right as soon as you see it. And that way I can go send it to tech support or something. It should be fine at this point. But it's been one of those sticky problems over the years. Okay, so not too bad in the end, though. The math isn't hard, at least. 8175. So I've got, this is kind of like a chemistry problem. 16% alcohol, if I could spell that, is mixed with 20% alcohol. So this is 2 different solutions. And then we have how many ounces, not ounces, of the 16% solution should be added to 6 ounces of the 20% solution to make a new solution of 19%. Notice that they're not saying how much 19% solution you're going to end up with, but that you need to hit that 19 mark. That's more important. Okay? So I'm just going to try to draw a little bit here. I got 16%, and I got my 20%. And I'm supposed to pour both of these into a new place here, and I should get 19%. Now, I don't know how many ounces I have of the 16, but I know for sure that I'm going to be adding 6 ounces here. Again, I don't know my answer here, how many ounces, but I know that it's going to be more than 6. I don't know, 7 ounces, whatever it is. So how do I tackle this problem? Well, notice it's going to be a systems of equations thing, mainly because it's in this section. And this is how I'm going to set it up. I have 2 different sets of numbers, 2 different rows here. I've got my percentages and I've got my ounces. So I've got 16x. Let's just call this x. X amount. X ounces. Something like that. And then I've got my 20% and 6 ounces. So I got 20% times the 6 ounces is equal to the 19%. And again, I don't really know what that is going to be a y. Well, here's the thing. I know that it's going to be more than the last one. Oh, did I put... Yeah, I used y. I kind of have an idea of how to go and do this right now. Just let's go ahead and put a y. That'll be fine. Okay, again, let's just call this one y. I don't know how much. I got an x. I got a y. And there we go. So we did this side right here. We did our percentages. But we still have this down here that I guess you could say just plain old ounces. I got my x ounces plus my 6 ounces should be my y ounces. I have 2 unknowns, 2 equal signs, 2 equations, and so then I should be able to solve this. And the first thing is I'm actually just going to plug this in for y. I was tempted to do that just a couple seconds ago, but I wanted to make sure to show you every little step to make it proper. Oops, I don't know why I was typing that twice. That was weird. Okay, there we go. So I just did the math here, by the way. It's just 1.2, and then I just plugged it in. Distribute. Six times 0.19 is 1.14. Combine like terms. I'm going to actually minus the 1.14 on both sides. I'm going to minus the 0.16x on both sides. 1.2 minus 1.14 is going to be 0.06, of course. Should have been able to do that on my own. So then 0.03x here. Divide to the other side. And you get x is equal to 2, I believe. Yep, 2. And that's, again, ounces. 2 ounces. They are not asking for how much we're going to get here. That's not their question. Their question was how many do I have to have here? So I have to have 2 ounces here, 6 ounces here, and then dump them both in together and mix them. And, of course, now you got 2 plus 6 is equal to 8 if you really wanted to do math. But you don't need that. They just said how much of the original 16% did you need. Last question, 8177. And yet again is another word problem. We have the North Campus, which has 20% of the students are music majors. We have a South Campus, where 30% of the students are music majors. It's a lot of music. They merged the two into a single East Campus. Now they have 24% of the students are music majors. We also know that the total students is equal to 1,000 students total. So then, what was the original students for North and South separately? Okay. I don't know how many students we had here. I don't know how many students we had here. But when I merge them together, I get 1,000 students, and 24% of them are music majors. Let's do some math. So first off, let's do percentages. And so far, what I've got is 20% of the North Campus, 30% of the South Campus, North, South, and then my East was 24% of the East Campus. Notice that I already know it's 1,000 total. And then finally, we want actual, like, just students, just plain old students. And so I got X North, Y South is equal to 1,000. Oops, not that many. Solve for X and Y individually. So I'm gonna move this over, and so X is equal to 1,000 minus Y, and then I could take that and plug it in. And so then I got 0.2 times 1,000 minus Y plus 0.3Y is equal to, I guess that would just be what, 240? I'm just going to verify. I'm not very good with decimals all the time. Okay, we're good. Distribute. So again, this should be 200 now times 0.2Y plus 0.3y is equal to 240. Combine like terms here, and I'm going to minus the 200 on both sides. So now I've got 0.1y is equal to 40. And if I divide by 0.1, it's kind of weird here. It actually makes it bigger, 400. And so that's the amount of students on the South Campus. Now, to find the North Campus, I could just take the 1,000 and subtract it. So X is equal to 1,000 minus the 400 is equal to 600 students in the North Campus. I guess you could say that's X if you want. Okay. Oh, apparently I didn't do any of that on my notes. I just said, nah, you can figure it out. Cool, so we did it anyways. All right, I'm sure there's other word problems in this section. I can't remember every single one of them, but I think one has to do with like hotel rooms with like kitchen sets or something. I don't know. There's all kind of things just like this, but this is the basics of it. If you have any questions, of course, you let me know. Thank you very much, and have a great day.